going to pick up with 3.3. So we spoke about did I tell you about the concavity test? How to figure out where you have concave up and concave down? I told you what an inflection point was. Let's talk about the concavity test. This is how you're going to test for concavity and inflection points. So, suppose your function exists at x equals c, and the second derivative at that point equals 0. Then we have an inflection point at x equals c if f double prime changes sign on either side of c. And that means f double prime goes from positive to negative or vice versa. So the test is the following. Set f double prime equals 0. Solve for x. Find the critical points. Put these numbers on the number line. And test the resulting integers. And we're going to do all this today, both for the first and second derivative, so let's see what this all means. Of course there's a quiz today, so pay attention. Okay, this is all it. This is all it. Conclude the concavity of each integral and where inflections occur based on the sign of f. How did the sign affect things? If f double prime is positive, what does that mean? How does it shape?
Happy face.
Happy face. Concave up like a cup. You lay up, happy, positive. This means concave down, right? So that you have to remember. And remember, it doesn't have to do with anything with increasing or decreasing. It has to do with the shape of the graph. If I want to find out about increasing or decreasing, what do I look at? The first derivative. Okay. So, as you might recall, the original function tells you about points on the graph. The first derivative tells you about maxes, mins, increasing, decreasing. The second derivative tells you about concave up, concave down, inflection. Right? So based on what you're looking for, you know what function to go to. So this is what the book calls a concavity test. They wrote it out in different language, but this is basically it. There's also the second derivative test. This is just an FYI. It's completely unnecessary if you did the first derivative test. Huh? At least we're accurate with grammar is an important thing. Okay, so.
Once math didn't have numbers anymore, you have to pay attention to the words and letters.
Not grammar.
Meanwhile, the English department being like.
So here's the test. Suppose f is continuous at x equals c. Then there are two cases. If f prime of c equals 0 and f double prime is positive, we have a local. That's what I'm going to ask you. What do you think the answer should be?
Oh no, if it's concave up, then it's concave down.
Right. That means this has to be a minimum. Why? Because this is positive, so you know it's shaped like a smiley face. Right? So that gives you a minimum. This would shape like a frowny face because it's negative, so this would give you a local maximum. This is called the second derivative test, but if you do the first derivative test, this would be obvious because you know it's increasing and decreasing. You know where the max and mins are. But this is just an extra test for the maximums and minimums using the sign of the second derivative at the critical point. But yeah. That's only if you care about that without doing the first derivative test. Otherwise, it's completely useless. Okay, so I think that. I'm just seeing if all the theories, then we can start to do some examples. Okay. I didn't finish it? I thought I did the table.
Oh, sorry.
I think I did. Yeah, I think we know enough to do examples now. Following functions. I want you to find all the things we care about up to this point. Find the intercepts that you started caring about since pre-calc. Intervals of increase, decrease, maximums and minimums, intervals of concavity, inflection points, anything I want to do? Yeah, that's good.
Professor, what does FYI stand for?
For your information. So let's start out easy. stuff I've been talking about since last class. Let's actually see it in action with these examples. For the heck of it, I'd probably actually define the domain. Shouldn't be too bad.
Find the domain intercept.
My God.
Okay, A, f of x equals 1 over x squared. Let's start with the domain. What's the domain?
Domain is x intercept 0.
X can't be 0, so minus infinity to 0, union 0 to infinity. Okay, that's great. What are the intercepts? If I want to find the x-intercept,
So y equals 0.
so y equals 0. This means y equals 0. This means 0 is equal to 1 over x squared. What's the solution?
There is no solution.
No solution. And if I want the y-intercept, what does that happen? X equals 0. Obviously no solution there either because you can't divide by 0. So there are no intercepts. Okay. Next thing, intervals of increasing and decreasing. How do I find that?
First derivative.
So increasing, decreasing, maxes, mins, they all come from the first derivative. So to get to that, I'm going to find the first derivative, which is going to be what?
-2x to the third power.
Right. So how do I figure out what's increasing or decreasing? Critical points. You find critical points. This means f prime of x equals 0 or undefined. F prime of x equals 0 means what? This is minus 2 over x cubed equals 0. Where does that happen?
And x cubed equals to -2.
Huh?
Nowhere.
With the x
Nowhere. There's no solution to this. The only way a fraction to be 0 is if the top is 0. The top is never 0. It's minus 2. F of x equals undefined means, of course, x equals 0 because you divide by 0. So this is going to be the only critical point that we're going to test. So what do? Like I said, you throw it on a number line, and you're going to test things in the first derivative because we're looking for increasing, decreasing, max, and min. Put your 0 here. Right? So now there are only two intervals to test, to the left of 0, to the right of 0. So we can test any numbers in these intervals. It doesn't matter what number you pick. So I'll pick +1 and -1 just to make things easy. If I plug in +1 here, what do I get?
A negative number.
I get a negative number. What does negative slope mean?
Decreasing.
Decreasing. So over here, I'm decreasing. If I plug in -1 for x, what do I get?
A positive number.
Positive number, which means increasing. So I know over here, I'm increasing. Is this point a max then? Why not?
Oh, right.
Right, notice that it's not a max. F is not continuous there. That's the point of the domain. It doesn't work at 0, so zeros can be nothing. There's nothing at 0. Okay. So there was one candidate for maximum, but he doesn't work. So there are no candidates for minimum, so that's it. So here, if I ask you for the interval of increasing, or ask you for the interval of decreasing, or ask you for the maximum or the minimum. So interval of increase would be max, none, min, none. What about inflection? What do I need there? The second derivative. Second derivative is going to be what?
Second derivative.
6
6 over x to the 4th. So what we're going to do is find the critical points of that.
0.
X equals 0 is the only critical point. So this means, again, I'm going to do a number line, but this time I'm testing the second derivative. Again, I can plug in minus 1 and 1 just to make my life easy. Plug in negative 1 here, what do I get?
Positive number.
Positive. Now, positive here means what?
Concave up.
What's that increase?
Minus.
I want something to throw. With second derivative, it tells you nothing about increasing or
Well, it's
decreasing.
about, it tells you.
Concave up.
Yeah.
Who said?
Plug in 1, what do you get?
Positive.
Positive. What does that tell you? Concave up. Increasing, decreasing is first derivative. We're in the second derivative. There is no increasing and decreasing anymore. Okay.
No.
Is there an inflection point? No. Even if the function was continuous here, there would not be because it didn't change signs. Right? It's positive on both sides. Okay. So,
Professor, would that be an asymptote at 0?
0 is an asymptote. Yes. We'll talk more about that when we get to 3.4. So domain is the usual business from pre-calculus. X and Y intercepts, again, the usual business from pre-calculus. That's nothing new. This is new, this is calculus. Increasing, decreasing maximums and minimums, you get it from the first derivative. Find the first derivative, find all critical points, put them on a number line, test the integrals. The signs are going to tell you when certain things happen, right? And you have to know the domain so that you can know whether this point exists or not, which means it can be something, maximum or minimum or inflection.
If it did exist, that would be a max.
If f existed at 0, this would be a maximum, yes. But here f does not exist at 0, so it can't be anything. It's an actual asymptote, which we'll get to in the next section. So once you figure out where it's positive, everywhere the derivative is positive, that interval is an interval of increase. Where it's negative, that interval is an interval of decrease. Hence, the answer is here. The next we look for concavity and inflections. This uses the second derivative. We're going to test it in the same way. Find the critical points, put it on a number line, test the intervals. And then the signs are going to tell you what it is. Here, you can only talk about concave up, concave down, not increasing or decreasing.
Wait, for the first derivative, that part, if both of them were increasing, would that be?
It would be
Would that be a
nothing.
max?
No. It's a max if you're continuous here and you're increasing here, decreasing there. It's a min if you're decreasing and increasing. Any other situation is nothing.
Professor, when you plug in the critical points in the first derivative, original function, you get the local max and min.
Yes, if you want to get the coordinate for it, which the y value is
And
your
let's say you
original.
want to find the absolute max and min, where would you plug in?
That doesn't come into play here. Absolute max and min, remember, only happens when you're on a closed interval. We even consider those. Usually. So it's not of concern here. We only care about the local
So
ones.
when you have the absolute max and min, where we have like a closed interval, right?
Yeah. You won't worry about that here, though.
So whenever we have the closed interval, we always have to state the absolute max and min? Or
If you're asked for it. The question will ask for it if it wants the absolute max and min. Otherwise, you just assume
So let's
everything.
say you want to find the absolute max and min, where would you plug in the critical values?
In the original function. Because remember, absolute max and min is a y value. You're looking for a y value. And you know
the
that the
highest
original
one is
function.
the absolute max, right?
The highest y value is the absolute max. The
That would
highest.
also be the local.
Yeah.
No, it's only local if this happens.
If they give you intervals, can you find the local maximum?
Yes, you check where this happens. Finding local maximum is always this procedure. This is always how you do it. Whether you're on an interval or if
So
you're
you
on a
don't
closed
care about
interval.
the intervals when you find local?
No, I'm just looking for a point where it's increasing on the left, decreasing on the right. That's a local.
You guys don't ask to explain why it's the local maximum, right?
No. No, this would be enough explanation. Okay, let's run through it again. We have 6 examples, so I guess by the time we get through all 6 of them, you'll have it now. Let's do an x to the 4th minus
4x squared.
4x squared. We're going to go through all this again.
We're gonna see this in the test. We're gonna see this in the test. Right, Professor?
Huh?
We never see this on the test.
No. Something like the last one could come on the test, even on the final one.
Yeah, I'm waiting for that.
Something like the last one.
No x to the right of 5.
So,
Oh my god.
all right, here, domain, everything, polynomial, right?
Yeah.
Intercepts. Let's say I wanted to find the x-intercept. This means y equals 0, so 0 is equal to x to the 4th minus 4x squared. How do I solve that? Factor out x squared minus 4. So you have x equals 0, or x equals 2, or x equals minus 2. Okay, so those would be the intercepts. What about y-intercepts? It's set x equals 0. So this means the y will just be, you plug in 0 here, you get 0. Okay, so those are intercepts. How do I figure out where we're increasing and decreasing? First derivative. F prime is equal to?
4x cubed.
Okay, so I need the critical points here. This means f prime equals 0 or f prime undefined. Doesn't work here, right? Or def always defined. Right? Because it's a polynomial again. And so we only check where it's 0. This means I need 0 is equal to 4x cubed minus 8x. How do I solve that? Back here, I can take out 4x, and I'll get what?
X squared minus 2.
X squared minus 2. So this means x equals 0, or x equals plus or minus radical 2. Now, what do? Throw those on a number line, and I'm going to test it in the first derivative. So here's my 0, here's my minus radical 2, here's my positive radical 2. Now, you might remember radical 2 is roughly like 1.41. So I can test 1 and minus 1. I can also test 2 and minus 2. Right? These are my test points that I have in circles. And where am I going to test them? In the first derivative. Right? So I'm looking at this expression here. Now,
We will test the x-intercept as well.
what?
We will test the
No.
intercepts as well.
Nope. Increasing only cares about first derivative.
Then why did you write down the intercepts of that?
That's going to be important later. If you're actually graphing the function, you need to know where the intercepts are. Right? So now we just want to test in the first derivative. So I can plug in minus 2 into this. This would be a negative number. This would be a positive number. So this is negative, which means what?
Down, slope going down.
Decreasing. Right? If I plug in negative 1, this is a negative. This is also a negative. So the whole thing is positive, which means increasing. Plug in 1, positive, negative. So that's negative, means decreasing. Plug in 2 here, positive, positive. That's overall positive. That means increasing. What can I say about these 3 points here?
It's concave. Oh.
You can't say anything about concave during the first derivative, or maybe throw something. This is a minimum because your function is defined here. It's a polynomial. It's defined everywhere. 0 is what? 0 would be a maximum. Plug in here, this would be a minimum. So this particular function has 2 minimums and 1 maximum, local. Now if I want to talk about where is it increasing, where is it decreasing, maximum? What's the minimum? Where am I increasing?
Negative infinity to negative 2. I mean,
No, radical negative 2 to 0.
oh, increase.
Minus radical 2 to 0.
And union
Radical to,
radical 2 to infinity.
Decreasing.
Negative infinity to negative radical 2. Union.
So what is my maximum point? X equals 0. This means 0, 0 is a maximum. Here's x equals minus plus or minus radical 2. This means plus or minus radical 2. Since this is squared, so the y value is going to be the same for both of them. What was it if I plug in radical 2? Radical 2 to the fourth is what?
4. Yeah.
Radical 2
Radical 2 to the
fourth
4 is
minus 4 times radical 2
4
squared.
minus 8 is minus 4.
So it's minus 4.
Yeah.
Our minimum points. Right? And notice for the coordinates, I plugged it into the original function, right? The original function gives you coordinates. First derivative, increasing, decreasing, max and mins. Now if I care about concavity and inflections, what do I look at?
Second derivative.
Second derivative. So now I'm going to find the second derivative, and I'm going to do essentially the same test I did here, but with the second derivative instead. Right? So the second derivative is 12x squared minus 8. So I find the critical points.
Wait, can you explain how you got the point for maximum? You plugged in?
Plug the x value into the original function to get the corresponding y value.
Okay.
So this means it's defined everywhere, so it's just where we have 0.
So 4 plus 3x squared minus 2.
This means I could take out what?
4.
I could take out a 4.
3x squared minus 2. Just 3x squared equals to 2x squared equals to 3. 2 divided by 3.
Plus or minus radical
Plus
2.
minus radical 2.
Now I'm going to test those 2 points in the second derivative. So I have minus radical 2 over 3. I have positive radical 2 over 3. I can plug in minus 1. I can plug in 0. I can plug in 1 into this. So if I plug in 1 here, that's 3 minus 2. That's positive. 0, I would get negative. Plug in 1, I would again get positive. So what does that mean here? Concave up, like a cup. That's the shape here. Concave down, like a frown. Up, like a cup.
I don't understand what you're doing. Critical line.
Huh?
I don't understand what you
I figured out where it's 0.
okay.
Put those numbers on the number line.
And then you circle the other numbers?
I pick numbers in each interval.
Okay.
Right? We'll cut it into 3 intervals. There's from negative infinity up to this. There's between these two, and then there's from this to positive infinity. So there are 3 intervals. I need to figure out what is the sign on these intervals. So I pick any random number. You can pick any one you want. So I pick 1, 0, and minus 1. And I plug it into
It's
this.
positive on minus 1.
Yes.
How?
This is the function. I plug in minus 1 for x.
So we plug in minus 1.
Yes.
Okay.
Minus 1 squared is just 1. 3 times 1 is 3. Minus 2 is positive. Times 4 is still positive. So it's positive here. 0 I plug in here. It's just 4 times minus 2. Negative. So that's negative. 1, I get a positive number. So remember, in the second derivative, positive means concave up. Negative means concave down. Oh, I didn't do this in the last one. Let me just explicitly write it out. Where are we concave down? Where are we concave up? And do we have any inflection points? Are there any inflection points here? Right, this would be an inflection, and this would be an inflection.
Well, because we changed
Because I switched concavity. On the left I was concave up, then I switched the concave down. For this one on the left I was concave down, I switched the concave up. Whenever you switch concavity, you get an inflection point.
Wait, what did you wrote on the bottom? Is that inflection?
INF, short for inflection.
Inflection.
Where are we concave down?
The from negative radical 2 over 3 to positive 2 over 3. Positive radical 2.
Concave up.
Concave up is from negative infinity to negative radical 3, 2 radical 3.
Yeah. To infinity. Okay. What are my inflection points? So it's plus or minus radical 2 over 3, comma. How do I get the other coordinate?
To the original.
We go back to the original, right? So that would be what? I get radical 2/3 to the 4th minus 4 times 2/3. What does that give me?
4 over 9 on the bottom.
4 over 9 minus 8 over 3, which I can write as 24 over 9. So it's minus 20 over 9. Those are my inflection points.
Wait, where'd you erase that? What? You plugged it in?
The original.
Plug this into the original graph, get the 1.
Wait, but we have two values, but I don't think.
Yeah, it's 2 separate points.
Yes, 2 separate points, but will we get the same y values by plugging in positive and negative?
Yes, because the powers are all even. The sign won't matter.
Oh yeah, it's because of the square, right? Square.
Yeah, I have a 4th power and a square power, so the sign is not going to matter.
So it's okay if we put it like that?
Yeah, these are 2 points. By the way, sorry of jumping the gun here, but could we graph that now in more detail?
I could, but I don't want to.
I'm dying to see this.
Boy.
So back in pre-calc, you just did your best approximation of a W, and that was good enough for your professor, right? In calculus, we expect a lot more detail. How would I actually put this on the axes now?
Intercepts first.
Well, put in the intercepts first. That's
It's
the
just
same.
like
That
a-
was 0.
Negative 2, 2. Yeah.
That means it was 2 and minus 2.
Yeah.
Okay. And what else do we know?
But we are
Just
graphing
go
that.
so go up and down.
Okay, where things go up and down, let's do that. So radical 2 would end up where?
Around between 0 and negative 2, yeah, right there. Over there.
So let's put here minus radical 2, put here radical 2, and the coordinates would be what? So 0, I know the coordinate is 0. I put minus radical 2, what's the y value?
No.
Minus 4,
The both ones.
right?
Yeah.
So this is at minus 4. Same thing with positive radical. That goes down to minus 4.
Yeah. 2 minus 4.
Okay? Do I know where the inflections are? We also did
Yeah.
that, right?
Is on positive or negative radical 2 over 3.
Minus radical 2 over 3, positive radical 2 over 3. And the y values were
We didn't get the y. Did you get?
minus 20 over 9, so they were very slightly negative. Okay, now let's talk about where we're increasing, decreasing, and concavity.
Wait, Professor, where did you get the y value for the?
I did it over here.
Oh, okay. That's
Okay.
negative 20 over 9, right?
Yeah, minus 20 over 9. Now the next thing I like to do, not everyone does this, but I like to have all the information that I got from here on the chart, because usually the calculation should be long, you don't want to be flipping back to the previous page, it gets annoying. So I put everything I figured out on the chart. So I know that this here is a minimum, this here is an inflection. I would label all these things very faintly. This here is a maximum. I would also put where am I increasing and decreasing? Well, from here, going back, I know I should be decreasing, right? between this and 0, I know I should be increasing. Here, I know I should be decreasing. And then from this onwards, I know I should be increasing. So I'll actually write that here so I can sort of see. Now I can put in my concavity, right, which is going to be here, all the way back. What's the concavity?
Concavity.
This is concave up.
And from
Here and
to positive, yeah.
Here.
Concave down.
I'm concave down.
And from radical 2/3
And all this way over here,
is
I'm
concave up.
concave up again. So this is all the information I'm going to put on the graph. So now I can actually graph this in pretty good detail. So I know I'm decreasing the whole time here, right? I have to hit this point and this point. How should I hit it? Concave up. So the whole time I'm decreasing, I have to shape sort of like a smiley face, right? So that's what that graph's going to look like. Going through these points, looking like a smiley face. I'm decreasing and I'm concave up. Once I hit this interval, I should be increasing on the whole interval. I know here I'm going to switch concavity at this point. So now I start increasing, but I still keep the smiley face shape until I hit that point. Between here now, I'm still increasing, but I'm concave down now. So I'm increasing, but now I have to switch to a frowny face. Right? So there's a little inflection point here. And it happens at this point, at -20/9. Now when I'm over here, I have to be decreasing this whole time, but up to here I should be concave down. So I'm decreasing, maintaining the frowny face. At this point, I switch concavity to concave up, so I switch to the smiley face. From here on, I'm increasing and concave up, so I'm increasing looking like a smiley face for the rest of the way. Right? So it's that W we got from pre-calc, but now the way you actually shape the lines will matter, right? So back in pre-calc, if you drew it like this, your professor wouldn't have cared.
Yeah.
We care now, right? This is telling me you said an inflection point is up here. Well, no, not according to your calculations. This is wrong, right? It matters the shape, everything matters now. You need extreme detail. That's why we go through all this, to find exactly where these things happen. Well, I basically just did all the 3.4. This is 2.4. I wasn't supposed to graph that, but the principles I just showed you is what we're going to do in 3.4. Like that's all of it. That's everything you need to know.
It's just graphing it.
Yeah, 3.4 is just sketching curves. It's curve sketching.
Sketching.
So it takes everything you learned from 3.3 and apply it to draw a diagram, which I just did. So let's do some more. Made a slight change to this function. Instead of the square, now I put a cube, which is probably going to be annoying, but this was supposed to be B. Let's do C. Okay. Domain, polynomial, all real numbers. Intersects. X-intercept, this means I'm solving 0 equals x to the 4th minus 4x cubed. And factor out x cubed. So x equals 0 and x equals 4. So I only have those two. Y-intercept, y equals 0. Just plug in x equals 0. Alright, so these are my intercepts. Now let's do increase and decreasing maximum. So here I'm going to need the first derivative, which is going to be 4x cubed minus 12x squared. So I find the critical points here. It's never undefined, it's a polynomial, so I'm going to just set it equal to 0. X squared is a common factor. This leaves me with x minus 3. So I get 0 and 3. Test these on the number line in the first derivative. And again, any numbers I pick is fine. So I pick, the smallest ones to give myself an easy time. So plug in negative. Now, here's where you have to notice little tricks with your function, right? I know that this 4x squared is always going to give me a positive number, so I can essentially ignore it when I'm looking at the signs. The sign's going to be controlled by the x minus 3. Got it. Here, plug in negative 1, it's negative. Plug in 1 is still negative. Plug in 4, it's positive. What does that mean here when it's negative?
Decreasing.
Decreasing. Here? Still decreasing. Here? Increasing. Are there any maxes or mins? Where? 3 is a minimum. 0 is not a max or a min, right? Maybe it's something else, we don't know, but we can keep going. So, we're increasing, decreasing, and we have a minimum. So we're increasing where? 3 to infinity. We're decreasing from negative infinity, right, to 3. We have one minimum point which occurs at 3 comma, when I plug in 3 to that, what do I get?
Wait, so you plug in 3 into the original. Where was it that you didn't plug it into the original?
Into the original, yes.
There was a...
So 3 to the 4th is 81 minus 12. That's the function of it. Oh, 81 minus is cube. I was looking at that. So what is this?
81 minus 108. Is that negative 27?
Negative 27. Remember, for coordinates, you look at the original function. Original f of x.
For any coordinate?
For any coordinate. That's why I gave you that table. F gives you the y value. No, this won't have a maximum. No local maximum. And it might have an absolute maximum if I slap a closed interval on it, but I won't. So now I want concavity and inflections. How do I get that? Second derivative. My second derivative, I get 12x squared minus 24x. Find critical points, always defined, so it's just say it's a 0. X is a common factor, I get x minus 2. So x equals 0, x equals 2. I'm going to test those in the second derivative. Plug in minus 1, plug in 1, plug in 3. Minus 1 here. This is negative, so this gives me a positive. 1 here, positive, negative, this gives me a negative. 3 here, I get positive. What does positive mean? Concave up like a cup. Negative mean down like a crown. Positive, up like a cup. Any inflections? We have both of them. Inflection here and inflection here. because I switch concavity and my function is continuous still. So if I want to know where am I concave up, where am I concave down, and where are my inflections, where am I concave up?
From negative infinity to 0.
It's infinity to 0.
Union 2 to positive infinity.
2 to infinity. Concave down, just 0 to 2. Inflections occur at 2 points, at 0, comma, put in the 0 into that, I get 0. And at 2, comma, plug in 2 into that, I get what? It's 8. And now that's enough to draw the graph, right? So let's see what this one looks like.
No, you don't have to. We didn't do 3.4 yet.
Well, we're doing it now.
No, it's so, but I want to learn that yet.
Let's get the white out.
Don't speak next time. I don't see the point in withholding the last step. It's just, you're guaranteed to have a problem like this on the final, and you're guaranteed to have it in the compulsory section, so it's something you need to know how to do.
Will it be on the quiz?
Oh, you mean on the first 17 points?
On the first section where you can't choose, you have to do everything.
Oh.
This is coming.
Nah, the truth part is going to be.
Let's see.
So you have to know it, so I think it's best I just run through the whole thing.
Can you do a sine
like
cosine?
over and over. Yeah, you can do sine cosine. It's very unlikely that you'll get one though. More than likely you'll get a rational function like the
But for your test, it's, you know,
I'd give you a rational function.
alright.
So we should not expecting the straight functions.
Highly unlikely. I wouldn't actually graph them.
It's okay, even if you do.
Okay, so what do I know now? Put in everything I know. I have 2 x-intercepts, right? 0 and 4. Okay, y-intercepts at 0, that's good. For the critical points, 3 shows up, right? And then I know I'm decreasing all the way up to 3. So this whole time I'm decreasing here, and then I'm increasing after 3. At 3, I know I pass through a negative number. This is the minimum, which is 3, minus 27. And that's everything that the first derivative tells us. Now you move on to the second derivative, and that throws in a 2 here. And I know at the 2,
X equals 2.
before 0, I'm what? I'm concave up this whole time between this and 2. I'm concave down for this little time, and then beyond this, I'm again concave up. And I know I hit 2 inflection points, 0, 0, and 2, minus 8.
Minus 8.
Yeah, someone told me it was minus 8.
Maybe negative 16. Wait, hold on.
You're supposed to plug in 2 here.
I did 2, 4, 16, 8, 32, 16 minus 32. 2, 4, 16.
Okay, so it's minus 16.
Yeah, that's 16 minus 30. Yeah, it should be negative 16.
For sure, I'm going crazy. It's minus 16.
Yeah.
Okay, so it's minus 16. And now we know everything, right? So I know I'm decreasing all the way to here, but how I'm decreasing matters, right? I have to be concave up while decreasing this whole time. So now I like that until I hit 0. Looks like a smiley face. I continue to decrease, right? All the way to 3 I have to be decreasing, but now in this window, I have to decrease concave down. So I have to switch from the smiley face shape to a frowny face shape. Still decreasing, I'm still in the decreasing region, but for this part of it, I have to be concave up. So I switch to the smiley face shape. Then for the rest of it, I'm increasing concave up. So this should be frown, smile, frown, smile, frown.
Where did the
Just
4 points
fine.
What 4?
come? So 0, 0, 2, negative 16, 3, negative
0 and 4 comes from the intercepts. 0 and 3 came from the first derivative. That's where my minimum occurred. 0 and 2 came from the second derivative, so these were my 2 inflection points. There's an inflection point here, and there's also one here.
Very long. Should extend the time for the homework. Because the homework is so long.
For
what?
3.3?
This section.
The written or the web assigned?
What was assigned both?
Oh,
Wait, 3.3 and 2.4.
Homework for this, I don't know what this is, 3.3 or 3.4? 3.3.
Well, only 3.3 would be due on Thursday.
Oh, that's not Thursday.
Oh,
48 hours.
Yeah, that's everything. So,
are we done with 3.3?
12.
huh?
We're done with 3.3?
16 hours.
Are we done with?
We're done with 3.3 basically, yes.
Yeah.
16
All the concepts we'll need are done. I'm just doing examples now to feed it into your brains.
No, 26. 26.
On Thursday, we'll do more of this, basically, with nicer functions.
When we get this problem, you will see a lot of frown face in your student.
3x to the fifth plus Anyway, this is definitely one of those problems that you really want to get into a routine. So you just keep doing it until you don't have to think about what to do next. It comes automatically. Oh yeah, domain, intercepts, okay, first derivative, second derivative, yeah. Right? That's how you want it to feel. Right? Because it's one of the longer problems on the exam, but it's compulsory, so you're going to have to do it. You might as well just get mechanical. Huh? Yeah, they will give you one question where they ask you for everything. Tell us where it's increasing, decreasing, maxes, mins, inflection points, concavity, and then sketch the graph. There will be one question that says all of that.
That should be worth 10 points or 15 points.
It'll be one question with that's all one thing, so it'll probably be worth 10. Depends on how it's going.
In the last questions, like in the big chunk, we can skip one, right?
Yeah, it usually comes in 2 parts. Like the first 70 points are compulsory, and the last 30 you can choose. That's typically how it goes.
Is that like a bonus question?
What would be a bonus? There's no bonus question on the final. Well, I need bonus questions because I'm nice.
Yeah.
Who's your
The bonus question comes with the tip subject.
Professor, I'm going to do it.
Right? So another polynomial, we're just polynomials are okay. I just want you to get used to it. The last 2 will be intercepts. X-intercept, how do I find that?
Equals 0, y equals 0.
So y equals 0, minus 3x to the 5th plus
So
5x.
x to the third comes out.
X to the 3rd comes out at minus 3x squared plus 5.
X equals 0. And x squared equals to 5 over 3. X equals to positive, negative roots 5 over 3.
That's going to be it. Okay,
Now we
so,
find the derivative.
yeah, plus or minus. So those are the intercepts. Now we find the y-intercepts. That's just y equals 0. now,
Let me find the second first derivative.
decreasing, I find the first derivative, which gives me minus 15x to the fourth plus 15x squared. Find the critical points.
Professor, you don't have to write x, f prime of x.
No. And so we can take out 15x squared, we'd be left with minus x squared plus 1. Right? Set that equal to 0 for critical points, so x is 0, or x equals plus or minus 1. Put those on a number line that we're going to test in the first derivative.
Negative 1.
0,
0,
minus 1, 1.
and plug in negative
What point would you, negative 2, what would you test here?
no, 1 over 2, negative 1 over 2.
Yeah, minus a half, minus 0.5, or 1 over 2, something like that. Here, positive 1 over 2, here I get to try this 2. It's usually easier to plug it into the factored form because you can see positive times
You
negative.
can just cross out.
Right. It's going to be more harder for you if you plug it in here.
No.
So if I plug in, and again, you notice these little things, this is always going to be positive, right? The 15x squared. So as far as sign is concerned, I don't care. This is what's going to control the sign. If I plug in a negative 2 here, that's negative. Plug in a half here, that would be positive. Plug in a half, plus or minus, is going to be positive. Plug in 2, it's going to be negative.
Do you have to plug it in the function after you factor it out?
No. It said it's easier to do it here than here. Okay, so what does negative mean?
It's going down.
Decreasing, increasing, still increasing, decreasing. Now, take you off, huh? Max or mins? Anywhere? There's a minimum here.
Max at 2.
Nothing. Well, it's not a max or min. You have a max here. Okay. So now, next we're going to write down where are we increasing, where are we decreasing, where do I have maximums, where do I have minimums, where am I increasing,
From negative 1 to 1.
decreasing,
From negative infinity to 1. Negative 1. Union 1 to positive infinity.
where do I have a maximum,
Maximum is
when x is 1, right?
yeah.
Now, how do I find the y value? It's a coordinate. I go to the original function, not the derivative now. Plug in 1 here, and I get 2. Minimum occurs at negative 1. If I want the y value of a coordinate, I go to the original function, plug in negative 1.
It's going to be
To
negative
the
2.
fifth, that would be negative. That would make it positive,
Negative
minus.
5 is
So it's minus 2.
Now we finally
Now we want to talk about concavity and inflections. Find the second derivative. What is that going to give you?
Minus 60x plus 30x.
So you find the critical points. It's always defined, so you just set it equal to 0. You can factor out 30x.
negative 2.
So x equals 0, or x equals plus minus radical a half. Test those in the second derivative. And plug in any numbers in these intervals you feel like.
Negative
So
1.
plug in a 1.
Between 0 and that would be
Negative a half still works. Positive a half still works. 1 still works. And now if I,
plug in the second derivative.
right, negative 1, this is negative. Negative 1 here, this is negative still. Negative times negative is positive. Concave up. Negative half here, negative. Putting negative a half here, I get a quarter. So this becomes 1/2. This is negative times positive. That's negative. Positive. Here, this would still be negative. Here, putting this as positive. This would be what? Negative. So, where am I concave up? Where am I concave down? Where are my inflections?
Negative at
Minus infinity up to negative radical half. And concave down to infinity. Inflection points, I only have one, right? There's only one point where I switch from a positive to a negative. So this is at minus that, comma, what's the y value? It's going to be ugly, to be determined. Okay, so, let's be honest. Let's be honest. It's going to be ugly. Ain't no denying it. So now we're going to go, we're going to put in all these nice points. 0 was one of the intercepts, radical 5/3. Minus radical 5/3.
Professor,
Yes.
I was having trouble with, when you plug in 1/2 in the second derivative, wouldn't you get positive?
Which one? 1/2?
Yeah. Because 1/2 is squared in the inside, right? Positive 1/2 squared would be 1/4. That would be 1/4. And when you cross that out,
4,
it's
so
gonna
it's
be
1 minus a half.
It's gonna be positive.
Here, yes. Would that happen here as well?
That one would
With a
not-
negative half, you, again,
That would be negative on the other side. It would be positive on the other side.
negatives here,
Yeah.
this would be positive, that's it.
But there should be positive. Yeah.
Okay.
0
So
to
now we actually have a couple more inflection points there. An inflection would happen at 0 then. So one would happen here, would happen at 0, and it would happen here. At 0, the function gives us 0. So I know the origin.
That's negative 2.2.
What?
That's negative 2.2.
Playing a calculator, that's cheating. Okay, let's see, what does the first derivative tell us? Critical points are what? -1 and 1. So this is a -1, 1.
Professor,
And I
you have
know-
to change the concave up. You have to add union.
Yeah, I forgot to change that. So concave up was minus infinity to minus radical half, union
0 to positive.
0 to positive,
Radical 1.
radical half,
Concave down.
concave down, would be this to 0, concave up would be concave down, again here,
Union to positive 1 or 2 to positive infinity.
see how easy it is to make a mistake? Okay. Graph will look completely different just now. Okay. So where do we have decreasing all the way down to -1?
What was our inflection point?
We are increasing all the way to 1. So we're increasing all the way here, and then we're decreasing again all the way back. And we have a minimum at -1, 1. -1, -2. So this here is going to be a minimum at -2. We have a maximum at 1, 2. This here is going to be a maximum 2. That's a maximum. And that's everything our first derivative tells us. Now we look at the second derivative. We throw in some more points, which is what?
Positive and negative radical 1 over 2.
-1 over radical 2, positive 1 over radical 2. We'll figure out where the y values are later. So let's actually, where is the concavity? Up to here, where would? We're concave up. The next one is between that and 0. So this little part here, we're concave down. Then this little part here, we switch to concave up again. And then for the rest of the time, we're concave down. So decreasing concave up. Then I am increasing, still concave up, until I switch up. So at some point here is going to be whatever our y value was. Now I still increase concave down. So I should look at a frowny face this whole time. Yeah. We're concave down. Concave up. Down. Then up. Down. Down. Yeah, there's some crazy curvature going on there, right? Yes. Up, down. That's what the graph would look like. Of course, in pre-calc, we draw this. 100 points.
I still got
So this is going to be an inflection point. This is an inflection point. Whatever the y value is when you plug it in, this would be an inflection point here.
On the test, we have to show the curvy, like make it really curvy.
Yeah, you have to show where it looks like a smiley face from where it looks like a frowny face.
That should be on the quiz as well, crap.
Yeah.
Quiz.
Of course, like right now. What do you mean? It's 2 pages. It's the hardest quiz ever.
What is it, Dream Killer Remix?
What?
What is it, Dream Killer version 2?
I would
Remember the second quiz we took was the Dream Killer?
All right, we're going to, so the last 2 examples we'll pick up on next time, and we'll do some more examples for 3.4.
Wait, what's that?
3.3 is done, do the homework.
That was good, actually. I like that.
Huh?
We have a quiz.